Graphs of absolute value functions. In general, absolute value functions are described as V-shaped. What we're going to do is find an appropriate viewing window that would show the key features, which are x-intercepts if they exist, a y-intercept, a minimum or a maximum value. We're given f of x equals 3 times the absolute value of 2x plus 5 plus 7. So moving to Desmos, so we have f of x equals 3, absolute values down here under parenthesis, absolute value of 2x minus 5 plus 7. My windows may be not appropriate just yet because I don't see that I can view my y-intercept. So I'm going to hit this wrench and I want to look up a little bit higher. So maybe let's go up to, looking up to 17 right now. Let's go on up to 30. See if that looks better. Looks pretty good. We have a y-intercept right there at 22. And we have this minimum value at 2.5, 7. All right, no x-intercepts. So let's bring this back over to our notes. And we needed to have a scale that takes my y-axis up to 22 at the very least. So I'm going to count by 2s. We had a lowest value at 2.5, 7. And I had my y-intercept at 22. And we've got symmetry, that V shape going on, and we're going to label it f of x. In class, we're going to do this exercise together. We were talking recently in class about square rooting and squaring, and how if I were to take the square root of something that was squared, they kind of cancel each other out. But more specifically, they are equivalent to the absolute value. Because when you square something, it always becomes positive. And when you take the square root, it kind of takes you right back to that value that you had. And so negatives in a square root of a square become positive. So let me show you. All right, so we're going to check with a table and graph on Desmos. I'm going to allow x squared to equal 4, and the square root of x squared, we're going to see if that equals the square root of 4. X squared to, and we'll have another line for when it equals 4. All right, that is 2 and 2. So we know that negative 2 squared is 4 and 2 squared is 4. That's good so far. And then they said to figure out what the square root of x squared is and allow that to equal the square root of 4. Let's look at that. So a new one, y equals square root of, and they said x squared. And to see if that equals the square root of 4. So y equals the square root of 4. Okay, and what's going on there? Let's get rid of these. Let's turn these top two off so that they aren't visible anymore. When does that happen? Again, at 2 and negative 2. So we can rewrite it that way. We're still getting the answers 2 and negative 2. So we're finding that the absolute value of 2 equals 2, and both x equals 2 and x equals negative 2 are 2 away from 0. I think we knew that. Now we can take that idea and take things that are square rooted and squared and rewrite them as an absolute value instead. So for example, this can be rewritten like this, the absolute value of 2x minus 1. And I don't know about you, but I kind of like that. With b, you might have to think about what factors you want to work with. Chances are there's a square hiding in there somewhere. 2x and 1, maybe. Yep, so this could be rewritten as 2x plus 1 squared, or the absolute value of 2x plus 1. All right, you'll try the third one. Now we're going to use absolute values to solve. And so let's do A together right now, and you'll do B yourself. We're going to put x in as 16. So we have 3/8 x minus 2 equals -8. 3/8 times -16 minus 2 equals -8. I guess we're just trying to see if this is true. Still seems a little like a weird question. So we now have 16 times 3, which I think is 52, over 8 minus 2. Does that equal -8? 52 divided by 8. 26 over 4, or 13 over 2. So we'll have that as positive 13 over 2, because absolute values get rid of negatives. Minus 2 equals -8. And so I'm going to take this opportunity to turn 2 into something that has got a common denominator. So we'll call that 4 over 2. 9 over 2. Is 9 over 2 equal to -8? No, it's not. No. So decide whether the given value for the variable is a solution. No, it does not. Last I checked, 9 over 2 does not equal -8. Let's see if this makes any more sense when we get to C. Okay, well, I think it's starting to, because now I have an inequality, and I have a paper that is changing sizes on me. So now we're going to put in pi. Well, that's not very much. Well, let's see what we can do. Pi. So we have 8. And I'm just going to stick pi in because I don't have a whole lot of space. Minus 9 is less than 8. Now, I'm going to use the decimal equivalent, or I'm going to approximate what pi is to see if I can make any more progress. I'm going to use 3.14 just so that I can make a determination here. And what is 3.14 minus 9? And then we will multiply that by 8. And we'll decide if that is less than 8.86. Okay. Now, if we were to take the absolute value, we would get 8 times 5.86. Is that smaller than 8? It's not looking good. And we'll get 46.88 is smaller than 8. So no, it's not a solution. Okay, but at least I'm seeing how there could be a solution. And so maybe if I had been asked to put in a number that was really close to 9 and then multiplied it by 8, that might have worked. But so far they gave me 2 that didn't work. Maybe when you put 6 in, it will work out nicely. We'll see. You'll let me know. Number 2. Given that f of x equals the absolute value of x, what is f of 2 asking in everyday English? Well, let's see. If f of x equals the absolute value of x, what is f of 2 asking me? Well, it's asking me the absolute value of 2. What does that mean? It's asking me how far is 2 away from 0. And the answer to that, 2, 3. Solve the equation by inspection, which apparently means in your head. So we're not supposed to use any sort of calculator, or we're not supposed to use pencil. We're just supposed to do it in our head. I don't like that. I'm always trying to get people to show their work. But let's see. 6 times some number plus 24 equals 0. Okay. Can I think of an x value that when I multiply it by 6 and I add 24 to it, and then I take the absolute value, I get 0. So I think I can do that. I'm thinking about right now trying to make this part of my equation equal to negative 24. And so I'm trying to think about, I know I'm drawing what my head is thinking about. Negative 24, so I'm thinking about what x value could make that part of my equation equal to negative 24. And I'm thinking that if x was, is it 6 times 4 equals 24? I sure hope so. Maybe if x is 4, that would be an answer. I'm also wondering if there's another answer. Could there be another number that allows it to equal 0? Because it does say numbers. I don't know. It makes me want to look at it graphically to see if there were 2. Let's see. Yeah, just the one, just negative 4. Okay, well, negative 4. Oh yeah, I'm making negative 24. Negative 4. I made a mistake. Good thing I checked my work. In general, this is just a review. The absolute value of x equals n means find all the numbers so that x is a distance n away from 0. There are usually at least 2 possibilities. We can go to the left and we can go to the right. So when you're given an equation with an absolute value expression, what you can do is you can set your equation to the left answer and the right answer, the negative answer or the positive answer. Let me show you what I mean. Now with this first one, it's pretty straightforward. There are 2 x's that could equal 5, 2 inputs. So we can allow x to equal negative 5, and we could allow x to equal 5. Now, if we have something a little bit more complicated, like in B, we're going to allow this to equal the 3, and we're going to allow it to equal the negative 3. So you'll write the first one, allowing it to equal the positive number. Write it one more time. And it could also equal negative 3. It's basically saying that if this stuff in here were equal to negative 3, and we took the opposite value of it, you'd end up with 3. So we're allowing that stuff in there to be 3 because it would end up being positive 3 after the absolute value was taken. So you can subtract 2 from both sides and continue to solve. We'll get x equals negative 7. And over here, we will get x equals 35. All right, go ahead and try that yourself. One thing to be mindful of is you don't want to set it equal to the 3 and -3 until you've gotten the absolute value isolated on one side. So when you're doing this independent question, you'll want to send the 45 and the 9 over first. And then you can break it into 2 pieces. Same with D. Are we done? Yeah, looks like we've got some group stuff coming. And I think I'm going to do the rest of this in class with you. Or maybe in another video. Man, there's a lot of stuff. Okay, let's see what we can do.